Today we're doing something slightly different from usual. I'm not going to go over a single topic tutorial. Instead, I'm just going to take you through my entire working process for designing, modeling, texturing and animating a character. Lately I've been doing a lot of character work for the enemies in my game, and I figured there's so many things that are not worth making an entire video about that are still valuable information, so hence this video existing. You'll have seen the finished result in the thumbnail. Obviously, since I am live commentating this, I don't know what the final result will look like, but I'm gonna go for a spider looking robotic artificial kind of being. And so my first step is to open up Stable Diffusion to generate some reference images that I can use to work off of. So I start by typing, I want a spider, it needs to be a robot, I want it to be made of stone, because that's the general vibe that I'm going for with my enemy designs. Probably glowing eyes. I do wonder if Stable Diffusion will actually give the spider 8 eyes. It's got real trouble with fingers, so I don't know about eyes. And then I'll just generate one single image to see what the kind of vibe is that I'm gonna get out of this. We then get this as a result, and that's definitely not what I want. So I'm going to add in 8 legs. That's a little bit closer, but it's focusing a little bit too much on having one eye, which is weird because I'm specifically stating 8 eyes. So negative prompt, we're going to say single eye or 2 eyes, 2 legs and 4 legs, because those will be the most common things that it's going to try to generate. So we're going to say you don't want to do that. And we're going to actually increase this CFG scale so that it's a little bit more respectful of our prompts. We're getting somewhere, but it's still not looking like what we want. And even though it's not technically correct, I'm going to add bug and insect, because that's probably going to trigger it to go more towards what a general spider would look like. Let's remove the robot and see if that maybe makes things just look a little bit more spider-like. Because so far, there we go, that's starting to look a little bit more like a spider. And that's actually a pretty good one. So now that I've got a prompt where I can trust that it's going to somewhat reasonably give me a handful of useful things, I'm going to change the batch size to being 4 and the batch count to being 16. This way it will generate 64 images at once. I could very well increase this to 32 and make it generate 128 images at a time. You know what? I'm actually just going to do that. It's gonna altogether take between 10 to 15 minutes, at least on my computer, and then I will have a bunch of images that I can use as a reference when I'm modeling. Alright, so the spider thing ended up being a bit more of an issue than I thought. So out of like 500-ish images, these are the 6 that I got, and then I got some real spiders and some normal illustrations off of Google to have a bit more of a baseline for the anatomy. Which finally gets us back into Blender, where I'll start off by deleting everything in the scene, and then we should probably start on the body itself, which is 2 spheres together, really. So let's add in the first sphere here, squash it down a little bit, and maybe, let's see, maybe that's a little too flat. Let's shake that smooth and see if we duplicate that and make it a bit bigger for the back one. Yeah, we're definitely going to want to have this one be a fair bit bigger. I think both of them probably. This may be a little bit higher as well. And then I'm actually going to subdivide both of these because they're a little too chunky at the moment. That's quite a bit better. Let's just feel free to apply both of those subdivision surface modifiers and get started on having the rough approximation of the legs. I think Putting that down will give the entire thing the most shape right away. So let's add a cylinder to begin with. We'll add a mirror modifier and use the main body here as the mirroring object. And then we can just rotate these around, make them a lot smaller. And we can get started making this, let's see, one here, two there, and one there, right? So we can also mirror in the Y axis. And then we're going to transform in the local space. So we'll go the Z axis, pull them out a little bit, and we're going to then going back to global, have them go up. And this is all more or less just to get a general feel. None of this is going to be particularly final. And here we're going to look at this specific image over here, where we can see that these legs have 3 segments, right? One coming from the body, then another segment here, and another segment here. So what we're going to do is we're going to add joints to both of these things. So what I'll do is, for now, I'll add a simple cylinder. I'll scale that down quite a bit. You can select the separate mesh here by just hovering over it and pressing L. That will select all the linked vertices or edges or faces. So everything that is physically connected to it. And then we're going to turn this around. Apparently I've got 2 of them. Somehow. Makes them a bit bigger. And this is how we're going to be making the joints. Is I'm going to inset both of these faces by the same amount. And then I'm going to press X and delete both of those faces. Go into edge select mode, selecting both of these edge loops. And then we're going to bridge the edge loops. And now we've got this donut shape. We could have gone for a torus as well, but I like the harder edges that we get in this method. So that's why we do that. And now going back into the legs themselves, we're going to scale this down a little bit and move it so that it's inside of our newly made joints. And then of course we can scale this and do whatever we want with it. I'm actually going to be adding a extra edge loop here that we're just going to slide along here. And that way we can actually scale down this bit. I've hidden this geometry here. That gives us a little bit more freedom to place this thing in a position where it should be without it clipping through and stuff like that. And let's add a couple more edge loops anyway to add a little bit of curvature. So we'll select this loop over here, turn on proportional editing, and then we'll just ever so slightly bend this. And then we'll just select everything here, Shift D to duplicate, and now we've got a second segment to work with. So we can rotate this around as a whole. And obviously the first thing we're going to need to do is make this entire thing, the entire leg, a bit smaller. So we'll just scale that down. But now in order for this joint to realistically work, there's going to have to be a sort of axle that goes through this that then connects to the rest of this leg, right? That's how this joint works, and that's also what we're going to need to do to attach to this object over here. So for now, what I will do is I will select these 2 things and then separate by selection. Eventually this is going to all move back into being one object, but for now this makes it easier. It still keeps the modifier on it, but now if we go back into object mode real quick, we can see that we have this as a separate object, which is just useful for being able to move it around a little bit easier. Eventually we're going to all mix and match this together to be one object again anyway. So let's add a new cylinder again, make it a whole bunch smaller, rotate it 90 degrees in the X direction, and then probably like 45 degrees or minus 45 degrees rather in the Z, and just see how that fits in this. That should fit reasonably well, not quite. We want this to be as parallel as possible, so do be careful about that and just scale it down a bit to see how well it fits. Alright, that seems to fit reasonably well now. Of course, this is not particularly physically accurate because this thing is now just floating in here. Nobody's going to come close enough in here for that to actually matter, so don't worry too much about that. And now we can simply just extrude or move these out a little bit. And now we're going to have to do something a bit funny because we need to put our 3D cursor in a reasonable position here to curve this around. So let's try to put it around here. So I've put it on here now, which is not ideal, but I think it'll do. 180 degrees. And this 3D cursor doesn't actually need to be in the perfect position because you can play around a little bit with the exact center point that you want. So this looks pretty good. And then we can just extrude this, and in theory, with auto mirror, I always get X and Y mixed up. Turns out what I needed was a auto mirror in the Z direction, so it literally didn't matter. These were merged together, and now we can also, let's see, it's going to be a bit tricky to get this working properly. Mix these together, hopefully. Let's see, in that direction, there we go. Let's hide this, just so that I can see what I'm actually doing. And of course, this is quite clunky at the moment, but we should be able to select this edge loop. First and foremost, make this a little bit better. And then with proportional editing, make this all just a little bit smaller. And if we say connected only, that's a nice little trick. It'll only influence things that are directly connected to it. So you can see this part over here. While it's in range, it's not really getting affected too much because it's not directly connected to the piece that I'm scaling down. Its influence isn't being decided by the circle of influence here. It's actually being decided by how far away it is from the thing that I'm influencing. And I think in general, this just needs to be quite a bit smaller, which then results in this needing to be quite a bit smaller as well. Felt a little bit big to begin with. Probably should have realized that a bit sooner. Probably not a bad thing if the outer ring is a little bit bigger though, because that'll also make it easier to mask this thing clipping into it, which I'm aware is slightly sloppy to work this way to begin with, but it works for me, so you just shut up. Well, now, this is definitely without a doubt too wide now, so going into wireframe mode and just selecting all these vertices, we can move them closer. And at this point, what we've made is pretty much just a torus. Yes, I am aware. Now, with all those changes being made, these extra second segments that we've just made are kind of worthless. So what I'm going to do instead is I'm actually going to copy over this thing first, add a new mirror modifier to that as well, and actually put this on the body, because now we've got a decent way to connect these things up, right? So we can go back into edit mode here, duplicate this stuff, and with a little bit of finagling, get that matching up there. And then it's just a matter of, and this is easier than it sounds, or more difficult than it sounds, I should say, getting this to properly connect to that, without it looking like utter shit, preferably. Well, it certainly ain't perfect, but it's something. So let's see if we maybe added a subdivision surface, if that would clean up my mess. Well, it makes these things look less rigid, which I'm not sure I like. Yeah, mostly what it does is it messes up with my rings here. I like the fact that these have sharp edges, though they probably should be at least a little bit beveled. So we can just add a bit of a bevel manually to them instead. That looks pretty decent so far. Okay, so now what we've got is we've got a system that we can use to link these things together. So what we can do is we can just copy this over, simply rotate it around a little bit. I think we can actually remove this upper one altogether. So let's remove these vertices, and then we can simply add that into there. And then, of course, without a shadow of a doubt, all this, I think what I'm going to do is I'm just going to make it smaller. I think that will do the trick just fine, and connect it like that. And then it's easier to scale this back up a little bit. Not too much, but a little bit. Look, ideally we would want these faces and vertices to actually connect. That would be best, but you can't always have what's best, now can you? And that adds our second segment to our leg. Probably want this ring to be down lower a little bit. And finally, I think we can apply this mirror modifier here. So that we can join these two things together as one object, which is separate from what I was just talking about. The fact that we ideally would want these faces to connect. It's just not going to happen. And one last time, we're going to duplicate this, move it down to roughly that last ring we've made. This bottom ring we're going to delete because the final segment here is going to be the foot itself, which we're going to connect a little something like this. And that was definitely the quickest and easiest one to do. It's a little bit high up compared to the body. Obviously we would want this to be below the body, but as soon as we've got this rigged up, we can just raise the body. And with this being driven by inverse kinematics, it will stay in the same position and everything will be fine. Hopefully. Now, let's select all of these objects per leg and join them together. And now we can see our entire leg is one object. All four of them, in fact. But a spider has 8 legs and not 4. So if we go back to our reference here, we can see that it heavily changes between spiders. I mean, these ones are obviously not great reference for actual anatomy. And neither is this because it's a illustration. Based on this one, the legs are about equal size. So at that point, it's literally as easy as just copying this over, moving them to here and rotating them around a little bit. And there we go. Which I think that brings us to the eyes as the next logical place to go. It looks like spider eyes come in a variety of different configurations, so I can be pretty creative with what I want to do, and I will not be. So what we're going to do is I'm just going to add a UV sphere, shade smooth of course. We're going to make that absolutely tiny, and we're just going to put that on its face. You know what's up, we're going to go for a mirror modifier, mirror it along the body. And then we're just going to add in a couple more eyes, and the exact configuration I am not 100% sure what I want to end up with, but I think this actually looks pretty good. Maybe we can make them a little closer together. I want some room here to have a couple of fangs, because I think that does give the entire thing a little bit more structure. But this probably, like this specific eye, probably could do with being a little higher up. Let's add a cylinder, scale it down quite a bit. We rotate it around the X in 90 degrees. We rotate it about 45 degrees in that direction. Scale it down even more. And simply shade smooth with auto. And then simply extrude, scale, extrude, scale, extrude. Scale. Probably scale this down a little bit or move it along there. There we go. Then selecting the second to last edge loop here with our proportional editing turned on. We're going to rotate this. Make it a little more fang-like. And we can rotate it around its own axis a little bit more. We do need to probably bevel these out quite a bit. Now that I look at it a little closer, because that looks a little chunky. That's quite a bit better already, actually. What does this look like when we mirror it along the body? Actually, that's pretty good. Let's go into the body itself here real quick and just move this along the local Z a tiny bit more. so that if we rotate this, it doesn't clip through, right? We're probably going to animate this a little bit in like the idle and running animations, so it's nice to have a little bit of room to work with here. And just like that, I think we have the basic shapes for our spider. That being said, now that we have all of this anyway, right, we can maybe increase the height of the body a little bit while keeping the legs at the same position. Increase the size of the legs as well, maybe. That's starting to look like a scary fucking spider. Okay, that's the base. Now we're going to have to add a little bit of like world building character, because in the end this is going to be a energy generating or a force field generating enemy, which will just like walk up into the middle of a battle and just generate a force field around itself to damage you. That's its entire thing, right? So it's going to need to have some kind of like generator on probably the back here, and the entire feeling of this thing is going to have to do it probably like electricity. So what I'm thinking is probably have all these eyes connected up to some kind of like wires that then go up to the back of its body, maybe, where it then splits back up into two separate wires with a generator each, and from there all the fancy stuff we will of course do in engine. That'll also give him some more interesting markings. So let's see, what does the geometry for that? It's not very nice, is it? Maybe that's more of a texturing thing anyway, I don't know. Okay, let's see, if I select this and this, I can extrude along normals. I can extrude these inwards. Then I can inset them quite a bit and extrude them back out. And from there we can extrude and scale and extrude and scale and extrude and scale and extrude. Maybe scale them up a little bit again. Extrude, scale them up a little bit more again. And extrude and probably scale them down, right? That actually works decently well, I think. Maybe the first extrusion was a little bit too much. So yeah, I think that works. I think that works reasonably well. Now, the only thing is I would very much like this to be a little bit more symmetrical. Because these are very, very twisted. But that honestly, like, if I just turn you around like that, that does the trick, doesn't it? Yeah, no, that is great. Maybe we can even like angle them back a little bit. Yeah, that doesn't work as well, does it? It's not ideal, but I do want these like little channels almost of energy to run throughout the entire body of this thing in the form of actual geometry. And I actually think that the shapes of the faces on the icosphere, while initially seeming like a not very useful mess, will end up helping this thing into looking somewhat decent. I do want it to be symmetrical though. I'm doing this partly because I want there to be physical detail on this thing, but also because this does make texturing a little bit easier at the very least. And it's not like this thing is particularly high detail as it is, so I can get away with a little bit of extra geometry, I feel. The only thing that I'm not sure of is if this is going to be like an animated texture kind of deal. On one hand, I do feel like that probably would be kind of neat. I'm also disregarding the entire thing about it having to be symmetrical, because I realize now that, in fact, a icosphere is not symmetrical to begin with, so who gives a crap, right? Okay, so if we do this and we bevel, that seems pretty good, and then I can extrude along face normals and inset them. That actually looks pretty cool. I like that more than I thought I would. I like that. We're gonna do the same for this, I think. But with the slight modification that we actually will change these vertices around to fit the eyes that we have made. I think that is a decent idea. Let's do this with the selection box instead. That way we can also have some of these like pathways between the eyes, and I think that would be kind of neat to have. So let's have between all of the eyes, we want to have these paths. That sucks because I need to have this. I guess that'll do. And then this one will be a little bit more random, I think. I think that makes a certain amount of sense. And the only reason I'm saying that is because it feels like this icosphere has gotten more fucked up to begin with. It's not really because anything makes more sense. It's just because it is easier for me to just pretend like that is the case. Also, a little bit of randomness in your design is not a bad thing at all. Matter of fact, it's actually probably a good thing, because otherwise things feel a little too predictable in a design. And that's generally not a great thing, having things feel too predictable. Too chaotic is also a bad thing, of course, but there needs to be a happy middle ground between the two. And that is what I'm trying to find here. I do think that this is pretty good, so let's try to bevel that. Something weird's going on here, I don't like that. If we then, yeah, so that's probably not the kind of look I'm going for, is it? First and foremost, this needs to auto smooth. Yeah, it's, hold on. This actually needs to go back up. Maybe if we make these paths in particular all a little smaller, maybe that'll do something good. Yeah, that's not it. But maybe this can still work as long as these lines aren't part of the entire thing. Right, so maybe we just frame the eyes in the insets. Maybe that works a little bit better. And maybe we can make a little bit of a mouth out of this. That would be kind of neat. And auto smoothing. That works quite a bit better. And that does add quite a bit of needed detail. It also makes this feel a little bit more like a panel, making it feel a bit more digital in some sense, which I like. So yeah, no, I'm happy that I tried this out. There's actually that's pretty good. I like that. Alright, we've got a model over here, and now this thing is going to need to be UV unwrapped. So if we go into the UV editing space and I set UV sync selection to on, you can see that the UVs are a goddamn mess. We could just select all and smart UV project, which would do a decent job of splitting everything apart, but as you can see, it's also making all these islands a total utter mess. And when we break this down into a texture, that means that we're going to have not a lot of resolution to be working with. So let's show that to you. We'll make a new material real quick. And over here in the shading tab, we'll then make an image texture, a new one, and we'll make a UV grid. The resolution really doesn't matter all that much, but since the eventual resolution is going to be 2048 by 2048, might as well do that. And if we connect that up into our base color, you can see what the UVs look like. And it's not too bad, but especially here on the face, things are a fucking mess. So back here in the UV editing space, we're gonna come up here to our options, turn on live unwrap, and then what we'll do is we'll just start selecting edges. So I'll say this edge over here, hold on control, clicking this, it'll take the shortest part there. And then the edge tag mode, I'm gonna set to tag seam. This way, every single time I click on something, it's going to tag it as a seam. And because we've got live unwrapping turned on, it'll automatically make a new unwrap. This way we can easily, very quickly create our manual UV unwrap, which in this case is probably not going to be that much better than the auto projecting, but part of this whole series is showing you my workflow and especially showing you when I run into issues and what those issues actually are. Holding Alt, we can select this entire loop and we can just mark that as a seam, and we'll do that for all of these loops actually. It's quite a lot of geometry detail onto this object, so the unwrapping process is actually going to take a little longer than any of my other enemies that I've made so far. And now that we've done a little bit of unwrapping, we can go back to showing the material here, and we can see the actual UVs and how things are scaled and all that kind of stuff, which is useful information. We can also see that all this black stuff doesn't have UVs yet, and as such doesn't show the actual texture. But using this we can also look around and see what parts might be stretched out a little too much and what parts might need a little bit more work on it. And every time we put down a new scene, you can see the actual textures update because they now have new UV coordinates. So I don't necessarily think that we actually need to put seams on these top edges, because as you can see, this doesn't look very stretched. We can probably get away with that without too much trouble. And if you want to make sure that that is the case, we can come up here and enable display stretch, and this will display the amount of stretch that your UV islands have. So you want this to be as blue as possible. The kind of green stuff, that's alright to have, not too much of it preferably, but it's alright. As soon as it starts going into the oranges, yellows and reds, that's where you have to really start putting down some more stuff. So you can see that there's a bit of stretching going on here because there's no seams. These squares are a lot smaller than these squares, and there's no cutting going on there. So the way we fix that is probably by edge selecting all of these islands in between. And I knew I was going to make things a little more difficult for myself when I made all of this extra detail with geometry rather than just doing it through a texture. But this does end up probably looking a lot better when we're finished with this. So I don't regret it. And it hopefully makes for interesting content as well, and if it doesn't, that's well, that's a bit of a pain for me, isn't it? Because then I'm doing this for nothing. If I wasn't live commentating, I'd be listening to a podcast right now, which would make this entire process a lot easier to deal with. So we can actually see there is a decent bit of stretching going on here after all, so maybe we'll need to put some seams along the top edges as well. I'm really hoping we don't need to, but in the end, we might not have much of a choice. Luckily, these two parts of the body, with all these little channels in it, is definitely going to be the most painful part to do. So the moment we finish this, everything else should kind of fall into place, is at least my hope. And if things get much too confusing, what you can always do is just select an object and hide it. Another thing to keep in mind while you're unwrapping is that you probably should have a decent idea as to how you're going to texture this thing. And I know that that's probably going to be the next video, but I'll give you a little bit of a insight into my process there as well. And that is that these little channels that are inset, that are extruded inwards, are going to have a separate material. In the very end product, that's probably all going to get baked down into one single texture and then into a single material again. But for the process of making those textures, this entire channel is probably going to have a separate material from these, for lack of a better term, islands, right? So having the seams being on the bottom here rather than on the top, I'm probably going to get rid of the seams on the top here, makes a lot of sense, because this over here, this face, is going to have to be the same material and a somewhat connecting texture to what's up here. While this channel down here is going to have a separate material on it anyway. So having the seam between those two faces makes the most sense. Of course, if I had thought about that a little earlier, I would have done this entire seam first, rather than having to do it now and then having to clear away the seam that I placed before. But as I said before, the entire point of the series is showing you my work process, and that also includes making dumb mistakes and fixing those mistakes. Luckily, if you use this method and you go over something that's already a seam, it'll actually just clear it from being a seam altogether. So this is a very easy way to fix mistakes like that. Sometimes it's a little iffy on not wanting to work though, so it's not great. And I'm missing some seams here, and that's why everything is being all stretchy and weird. So we go back to placing some more seams until everything is all seamed up. And remember, this is only one of the 2 body segments that I need to do. I've been at this for 20 minutes. Complaining about tedious work is also part of my work process. It doesn't serve any productive functionality other than keeping me from going actually insane. And this is why smart UV projecting, even though it's not entirely perfect, sometimes preferable. So if you want to check whether or not something is entirely isolated and not connected to any other islands anymore, these are the UV islands, you can just hover over it in face select mode and press L, and it will select all of the linked islands over in this side over here. And then you can see, okay, so I've missed this island over here. Going back into edge select mode will then allow me to quickly unwrap around this island. Then pressing 3 to go back in face select mode, selecting all of the connected things for the channel down below. And this seems to be, we've got another one over here. And now when we look around, there's nothing else linked to this. So we can take a look over at this side and see if that's all pretty blue. There's a little bit of stretchiness going on here. So we can select these faces, just like a handful of them, and see which ones those are. I'm assuming they are these ones. Alright, so the best way to do this, it's this outer ring over here. So if we edge select, we can see it's not this one. This one seems more or less fine too. The edge flow is a little fucked up here, that's a problem. Oh, and as we can see, the reason that this is all stretched over here is because I didn't actually close this loop with seams. So now that I've done that, we can see the stretchiness problem is all gone, and this now kind of looks like the labyrinth of paths that we've made over here without too much stretching. Now we can see that all these separate things over here are the islands that we've made, and they are all a little bit stretched. So instead of making an entire go around making the top rows here all seams, which is not going to do too much in reality, what we can do is we can just pick the point where there is the most stretchiness over here. Then with the period key on the numpad, we can orbit around specifically those vertices, or edges in this case, and just mark that specific edge as a seam. And as you can see, that immediately solves a lot of the stretchiness problem. So we select this one as well, go back to our active window here and mark seam. You don't even need to see it. All you need to know is that there's stretchiness going on here, right? So as long as you have a reasonable idea as to what the vertices you're selecting are, you don't need to know exactly what you're working with. So let's just select all of these edges and mark them all as a seam. There's a couple more that we need to mark as seams. We can do this one as well, that's okay. And they don't need to be all just perfectly blue, right? As long as they are not too green, then that's fine. Like, there's a little bit of turquoise going on here for sure. I don't really mind that too much, so we can just leave those alone. Alright, that's the main body UV unwrapped. Now the legs. Let's hide the main body here, the head, so that we can easily get into the legs. And this actually isn't going to be as difficult as you might think, because we can just edge select this and then select a ring around here. And just that will be enough to unwrap this in theory. For some reason, these aren't connected to each other, which is not great to begin with, but we'll just ignore that for now. And as you can see, that is a properly unwrapped little joint thing point. And now we need to do that for all of these other ones as well. Isn't that great? So realistically, what we should do here is we should have unwrapped this before applying the mirror modifier, because then I would have known the seams for all of these legs are gonna be in the same place. We didn't do that, so now we have to manually do all of them. Luckily, it's not really that difficult because we can literally just like click, 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 3 clicks on every single one of these legs, and that's all it takes. The legs themselves gonna be a bit more of a pain to deal with though, but in the end, those are more or less just cylinders as well, so they're gonna be easy to unwrap. Those very basic primitive shapes, you can get away with being a little sloppy with them because they're quick to unwrap. Same with the fangs here, we'll do them in a moment. We'll mark seam for all those at the same time, and there you go. All those chain links now unwrapped. And in a pretty undistorted way as well. I mean, there's a little bit of distortion there, but that's going to be very small details, so it doesn't really matter. I'll do the eyes as well now. Unwrapping a sphere is just a matter of cutting it in half. That's good enough. Especially since these eyes, if they're a little bit distorted, that's not going to be too big a deal because they're going to be a single color that's just going to be emissive. So there's not going to be too much like tiling issues or unwrapping issues going on here at all. So I'm being a little bit fast and loose with where I actually put all of these seams for the eyes because it literally doesn't matter. And we can unwrap those as well. Now for something like this, which is closer to a normal cylinder, we select the bottom face and the top face and then just one line connecting the two of them. And we unwrap that, and the fangs also unwrapped. And for these little buggers over here, that's going to be a little bit more interesting because we need to select this edge over here, as well as this edge. You can select an entire edge loop by holding Alt down, if I hadn't said that already, by the way. Only if your topology actually flows well though, which in my case is about half of the time. Then we also need to select these rings on the inside. And then we simply just select a ring going in this direction, preferably one that's going to be more or less obscured by the body itself, so on the inside here. And we'll just do that with every single one of these. And just like that, we've done one side over here, and now we just need to do the exact same thing over here on the other side. I try to be somewhat consistent in where I put the seams between the different legs. Sometimes, especially with like these horizontal seams, they're not in the exact same position. In the end, that doesn't matter too much, so don't beat yourself up with that kind of detail. As long as it's in a functional place where it works, that's all that matters. Your eventual player or viewer or whatever you're making this for isn't going to know that. Now, the entire process for doing these two shapes, we're going to do again for every leg, for this one, and this one, and that one, and that one. So I'm not going to go over all that because that's just repetitive and boring. But I want to show you that, in fact, if we hide everything here real quick, these legs are really still just cylinders. So what we can do is we can go into face select this face, select this face, going back into edge select, just select a random line between the two and unwrap those as well. And now we've done that as well. So if we now unwrap this entire thing with everything being selected, because everything that you've got hidden is not used in the unwrap. So we've hidden a few things, now we've unhidden them, and you can see everything is a mess. That's not a big deal. We can just press the unwrap button, it'll unwrap everything again. And you can see that pretty much everything about this at this point is the same process we've done, just these joints we'll have to do like another 8 of them, and then the legs themselves we have to do another like 15 of them. And we have to do the same process here with the back part of the body as well. I think the only really interesting bits we've got left here would be these two like tower generator things. So let's do those first, and then we'll just skip to the final results after that. So realistically, this isn't going to be too different from a cylinder because we just select the edges around the bottom and then the edges around the top. But the same thing I said before about the little channels over here, which are going to be a separate material, at least for the texturing process, also holds true for the tops of these things. Because these faces, that being all of these faces together, you get the point, are going to be a emissive color. So I could, if I wanted to, put the seams up here at the very top edge. But instead I'm going to put the seam over on this edge instead, because this is going to be a edge between materials anyway. And I don't really have to worry too much about these faces being slightly stretched, because in the end that's going to be one solid emissive color. So there's no texture there to get stretched. So then I just take a line from the top to the bottom of this tower, and you can suddenly say it's beautifully unwrapped. We just do the same thing on the other tower as well, and then there's just a lot of repeat actions for the rest of this unwrapping, which I'm not going to bother you with, because you've seen my process now, and from here it's just tedium. And as I've said before, I like to listen to a podcast or something like that while I do things like this, and I would very much like for the remaining hour and a half of this process to be able to do that. One last thing though is I'm going to make this symmetrical so that these seams, if there's any texture seams at all, I'm going to try to prevent there to be any texture seams that are too obvious. But if there's any seams at all, at least they're symmetrical and they're visually somewhat pleasing. And after a long little while here, we've got everything unwrapped, and you can see the UV maps here over on the left hand side, where you will be able to see that there is a fair few things that are very small in scale. Things like the eyes and the links between the leg portions. Those aren't going to require too much detail anyway. The automatic packing process is pretty good at looking at the difference in scale on the model and maintaining that in the actual UV maps. That being said, sometimes there is an argument to be made for cutting things up a little bit more, just so that they can be packed a little more tightly. There's a lot of wasted space around here and around here. So what I'm going to try to do is I'm going to select a couple of edges here. This material is going to be a solid color or close to a solid color anyway. So it doesn't matter if I cut out a couple of things here or cut loose a couple of things rather. And especially for parts like these ones, where we are clearly going around one of these energy towers, we probably want to disconnect those anyway. There's no real good reason to keep those connected, and it only takes up empty space. As well as helping, in theory, making things that are stretched a little bit, like this light blue over here, stretch a little less. Not significantly so, but technically speaking. That's pretty good. So over in the viewport being selected here, I can then mark those all as a seam, and it will automatically unwrap everything again. And from here, it's a little bit of a puzzle, right? So what we can do is we can go into face select mode and select the big space wasting islands, such as these over here. And assuming we have individual origins as our selection mode, we can just scale those down. These are going to be solid colors anyway, so it doesn't matter too much if they're scaled down, because they don't need to have a lot of detail in them. All they require is a somewhat decent amount of room to have a color applied to them. And then I see we also have this one over here. Where did that actually end up in this UV mess? We have that one, and then probably also this one is a good one to probably scale down. And then I think these two, they can all be scaled down significantly. And now we'll look over the model. Is there anywhere on this body that's scaled significantly differently? One thing to keep in mind is that when you scale the UVs down, the texture scales up. So let's scale this back to what it was before. And while I scale, look at the texture over here, right? So now I'm scaling this up. That makes the texture smaller. And if I scale it down, that makes the texture bigger. Anyway, so now we've cleared up quite a bit of room, so we can select all, press F3, and type in pack islands. That then intelligently packs all the islands at their current size, and this way we can take a look around. The eyes don't need a particularly large amount of detail either, so we can select all of those as well, because again, these are going to just be a solid emissive red color, and we can scale all of those down. They need to be big enough to actually like register a couple of pixels of a emissive map, but nothing beyond that. And this is not UV unwrapping related, but I realized a moment ago that there's actually a face on the inside of this model. So if I go into solid view here, you can see this is a face, which it shouldn't, but it does have a face. So let's remove that face, because it is taking up UV space and we don't want that. What we can also do is go select by interior faces, and that will now select all of the interior faces in the entire model, and we can just delete all of those faces, and there we go. That helps quite a lot faster than doing it manually, and also helps if there's any inside faces that you might not be aware of. So this entire part of the body is one island, and that seems a little much to me. So we're actually going to cut this up into a number of different smaller islands. And the best way I can think of doing that is putting seams on all of these lines. Either that, or a other potential option would be putting seams along the tops here. That would probably be less obvious actually. Let's do that instead. You'll note that I accidentally used the live unwrap, and now the channels over here, which I scaled down before, and likely the eyes as well, are back to being big, which is annoying as hell. So sometimes you might have to go through these kind of things a number of different times, which is just kind of the way the world works. I just really wish that when it unwrapped the thing, it would remind itself as to the sizes of the islands, because I needed to make a little adjustment, and now I have to redo all that again. But you get the point. Next time we're going to get into texturing this thing and the way that my process for that works without being able to draw or paint to save my life. Still being able to make nice looking textures for your models. We've modeled and we have UV unwrapped this entire thing, and now it's time to get started texturing. And I'll show you my workflow for that, which I think is actually a pretty interesting workflow, because I can't draw or paint all too well. So what I end up doing is going back into layout mode here for a second. I start off in edit mode and I select, in this case, all of the eyes, because these are all going to be emissive and red. Then I make a new material and I call that, let's say, just eyes. And I assign that new material to all of the things I have selected at that specific time. And this is going to be, if we switch into material preview, base color black, and then the emission color is probably going to be like red or something like that, right? And this is going to create a pretty big list of separate materials for separate parts of the mesh. In the end of the process, when we finished all of the texturing, we're going to bake that all down into a single texture, then bring that back into a single material that we can then easily use in a game engine like Unreal or Unity without having to import a absolute boatload of different materials and different texture maps, and that just being inefficient. So I know that these little channels that we've created here are going to be a separate material as well. So we'll make that a selection. And then of course also the back part of the body is going to be the same thing. The channels are going to be their own material. So now with all of that selected, again, we'll just make a new material. We'll call this energy or something like that. And for the time being, I'm just going to make the base color for that a light bluish kind of deal. We'll assign it. And this way we start getting a decent view as to what the rough approximation should look like for all these different things. Now, the towers themselves are going to be a separate texture. There might be a little bit of texture painting going on here, because I don't think we're going to be able to do this entirely procedurally, but I'm going to try. Because again, I suck at actually painting. So let's make that a darkish brown kind of color. Then the two body parts, which are a lot of different little islands and segments, are going to share one material. And I think the mouth itself is going to be separate materials from body, I want to say. So we'll make a material for the body. And for now, we'll make that a different shade of brown. Of course, the fangs are going to be their own separate material as well. And now we get to the interesting bit, because I'm not entirely sure what I want to do with like these mechanical joints as far as materials go. The legs themselves obviously are going to be a separate material as well. It's probably going to be a dark black kind of material. So let's make that black just for previewing purposes. Then the tops of these towers are going to, what should I call this? I'm just going to call this a leg for electric. Because that's what it's going to be in the end. And then I'm thinking this and this is going to be one material, and then the middle part is going to be a different material. So we can create a mouth outer and a mouth inner. I think I'm going to make these circular and these more torus shaped parts of these joints both the same material, is what I'm deciding right here and right now. I actually don't need to make a new material for this, because I already have a material that's only those things, because that's the only thing that's left. And we can just remove that texture from this, and now we have a, let's make this like a dark blue. That's not the color it's going to be in the end, but now we have a rough approximation of what the like color blocking is going to look like for this guy. Again, with the exception of the blue here, because I don't know what I'm going to do with those yet. And now we go through one by one and design these procedural materials to go onto this object. So let's start with the body, because I want to start here with a Voronoi texture. And I'll just preview what that looks like. I actually want to have the distance to edge. Let's add some mapping nodes here, because we want to use the UV for this, because we UV unwrapped this thing for a goddamn reason, didn't we? And then we scale this way down. This is now a gradient. I want these to be actually like harsh lines. We can do that in a number of different ways. We can say a less than node, which gives us the option to create a map that looks something like this. And I actually really like this. For now, let's put that into a mix color node. And we're going to use that as the factor. And that's going to go into the color for our principal BSDF. For now, we can just pick two colors. So let's go with a brownish color. And let's go with black. And we want to set this bottom one from being color to being mix, so that it actually like mixes between the two of these, and that then creates this kind of cracked looking effect. These lines might be a tiny bit too straight though. I mean, they're pretty fine, but having a little bit of wiggliness to them might actually look a little bit better, is what I'm thinking right now. And also the contrast to them needs to be significantly higher, so we want to have them be like actually black, and maybe have this be a little bit brighter. Anyway, what we're doing is creating wiggliness, and the way we're going to do that is coming off this mapping node. What we're going to do is we'll pull off and get a mix linear light. Putting off the same mapping again, we'll actually get a noise texture this time using the same mapping coordinates, and that's going to go into the bottom here. And if we then use the output of that as the new vector for the Voronoi, we'll be able to see everything gets distorted. If we put this down to 0, it's entirely non-distorted. If we put this up to 1, it's a really weird looking mess, which also a neat effect, not what we're going for right now. So this distorts the lines a little bit, but not quite in the way that I was anticipating. And that is because if we preview the noise texture, it's really big. Like there's hardly any noise going on here. So if we increase the scale here, we can actually start seeing the noise texture. And if we then go into the Voronoi texture, or rather the less than, for a better view of things. Let's just go into the principal BSDF actually. We can start seeing that that might have been a bit much, to be honest. Let's go for like 50. If we up the roughness as well, that also creates some more detail. That can help in making things a little bit more jagged instead of all wibbly wobbly. And it only needs to be a little bit of distortion. But as you can see, now the lines here are no longer perfectly straight. So we can maybe 0.03. That might be a little much already. 2. And of course we can layer this in multiple layers. So if we want to just like copy and paste this over, create a second noise texture here. And then the output from that linear light goes through this one. And that then goes into the Voronoi texture. Now we can also make a noise texture that is a little less rough and a little less detailed. And creates more of the bigger wibbly wobbly kind of distortions. And that one we might want to put up a little higher in the mixing factor. And now we have a decent look for like the cracked shell of this stone, like ancient golem kind of being. That's all fantastic, but that is all just to generate the lines between what's going to be the actual texture. So the actual texture itself, I am not entirely sure what we're going to do with yet. So I'm going to start with a Musgrave texture, which is a different type of noise texture. And we're actually going to use the same mapping coordinates for that as well, using the UVs. As you can see, it's a more rough kind of noise texture. Compared to the way this noise texture looks, which is a lot softer, this is a lot more individual blobs of white on a black background. And if we lower the dimension value of this, that's actually pretty good. I think I'm going to use that. And we're going to put that into a color ramp. Anyway, so let's make a dark brownish kind of color for the base color. And then the dirt layer that's on top of that is going to be... It's a very good question. What color are we going to make that? A slightly lighter brown seems to work quite well, actually. That's not bad. I quite like that. We can put this into the mix color now instead. And now we'll see that instead of just being that one solid color, this mix color will now mix between the texture we just created and the black lines. Now, for the time being, I'm just going to increase the roughness here by quite a bit. We'll eventually make a roughness map, most likely, as well, but I want it to be fairly non-reflective. So, you can give detail to your textures with color, but what's probably more important in a lot of situations is creating a pretty good normal map. And that's what we're going to be doing next. So, we want to, for the things beneath the dirt, have a certain normal map. So that light interacts with that a certain way. And then the dirt itself is going to have a different normal map. So that light interacts with it slightly differently. So first and foremost, let's pull off this again and let's see what type of texture we want to use for this. Probably just a normal noise texture, to be honest. But we could use a magic texture. Just let's look at what that looks like. I don't think that's gonna do it. What if we put this through a separate color and just look at the red or the green or the blue channel? Okay, interesting. This is a pretty interesting pattern to keep in mind. I've never actually worked with this before, having them separated out like that. And I actually think that this might be a pretty fun pattern to work with. So let's go for that right now. And put that into a color ramp so that we have influence over the contrast. It's not good for tryptophobia, but then again, this is also not good for arachnophobia. So if you've got any type of phobia, don't watch this video. Anyway, the output for that is going to go into a bump node. And instead of the strength, it's going to go into the height value. And we'll plug that into the normal here. And what does that look like? Okay, so we don't want it to be too contrasty, but maybe if we like lower the white a little bit, that looks interesting. Not really. It also gives him a leathery or scaly kind of look, and I like it more than I thought I would, to be honest. Maybe the strength can be a little bit lower. Oh, hold on a moment here. This is kind of neat. If we increase the strength back up. Yeah, I like this. It's kind of like a in-between of a... Well, it's not a honeycomb, because a honeycomb is a hexagon, and this is just squares. Slightly distorted squares, but it's just squares. So it does give that kind of scaly look, which is... Again, I don't dislike it. Alright, so yeah, let's go with that for now. And we'll take this color output, and actually, before we do the bump node, we'll multiply this with the output of our Musgrave texture. And you'll be able to see that we now, if we set the factor to 1, we only have this bump map, which we're going to be using in the places where we don't have the dirt. So if we put this into the height, we'll now see that wherever we have that dirt texture that we've made before, the lighter brown, we shouldn't have... Okay, I just needed to pull it through a color ramp node. And there you can see this is actually the wrong way around now. So if we put an inversion node there, we might need to put a color ramp in between here as well to make this effect a little stronger. And the great thing is we can just pull this through another inversion node again, and we have the exact same mask now, but for the actual dirt texture. So we can just create, and for this we're just going to simply go for a normal noise texture, because that's pretty good. And what we do is we just scale the ever-living hell out of it until it's very, very small. We pull it through a color ramp just so that we have some control over the contrast there. We multiply it with the negative mask we've just made, and that then can just go into a new bump node, into the height, where the normal from this one can just go into the normal from the one we already made. And as easily as that, now our dirt should have some detail to it as well. It's in need of some definite polish. I'll be the first to admit that. But I do like the idea that that top layer is armor, so maybe if we can use a Voronoi texture for that. Because we can do something similar to what we did before, and that's using the distance to edge. Scaling the ever-living hell out of it. And then decrease the randomness a certain amount. Making it a little more uniform. And then putting that into there instead. And then we probably want to invert this. And we invert the bump map again, because we just keep inverting things left, right, and center. Put its strength significantly higher. And maybe even up the distance a little bit. The reason I like this is because it actually kind of looks like a spiderweb kind of pattern. Together with also making it feel still a little cracked or old. And you could also interpret this as being like pieced together armor piece that I've flaked off, as we talked about before. So I quite like this look. Now I do think that adding a little color variation to this as well, on top of having different like normals for those bits, is probably a good idea too. So let's see, what output do we need for that? That's this. So we'll just copy over this mix color. That'll be the factor. It's kind of faking ambient occlusion this way, right? And I kind of like that. My only question is, should it be black? Or should we go for a slightly different color? Like, it could be cool if this has a little bit of like blueness to it. I think that is a good start for the body itself. Now, in order for everything to not entirely shit itself while I work on the other texture, I'm going to disconnect these two things. Specifically, the normal map is probably what's causing most of the... Yeah, so we can keep the color map for a little bit of reference while we're working on the rest. But we'll reconnect the normal map at the very end, because we have quite a bit of calculation going on here to calculate the normals. And that's just pretty computing intensive. So let's move on to something a little easier. That being the legs. I feel like the legs are going to be relatively easy. I want to start off with a wave texture and just see how that works out, we can, let's see, use the UV coordinates for that. If we increase the scale for that, it actually follows the curves of the legs, which is fantastic. I was afraid that I was gonna have to rotate it, but then again, you could just like rotate the Y and Z in theory. That should work, right? But it doesn't look like I had to do any of that. So this allows us to have a, well, waving texture that's more or less just a sine wave, and add some distortion to it to make it a little less rigid. We can also add some detail to it, which usually it's a good thing, right? Adding detail. We can give it more roughness, which is, it's slightly different from the actual detail function, but it adds more visual detail as well. And we want to make sure that with the face offset, we create a texture that blends this together decently well. In case you're ever doing something like this and you have your UVs packed in a way that creates lines the wrong way around, you can just say use the Y value instead, and that creates. That also is kind of cool though. I think I like this one a bit more. Let's add some color and see how I feel. And of course we do that through a color ramp node. And as I said before, this is going to be a pretty dark material, mostly black and dark gray with maybe a little bit of a blue tint to it. That could be cool. And this is slightly lighter, but not by much. And let's see if we increase the contrast on that a little bit. Now compare that to, now it just looks like he's wearing striped socks, which is not great. So I think this is the better option here. I feel as if maybe copying over this texture and making a version of this that's just like non-distorted. And by the way, you can increase the detail all you want. So if you don't have any distortion, it's just gonna be a sine wave. Maybe doing that will actually look better without all the unnecessary added detail. I mean, it's a little sharp, but that we can fix with a curve. So if we just ease this a little more. And I just realized we don't need the invert node. That's just dumb because we have an invert button, like a checkbox here on the bump node itself. Still not really doing it, is it? Nah, let's just ignore that idea. That just didn't seem to work out so well. What we'll do instead is something similar to what we did before. And that is use a noise texture. Scale the ever-living hell out of it. And then just multiply that with the wave texture. So we only get those normals now on the parts that are white, and the parts that are white are the purple parts. So in theory, if we now put this into a bump node, that should give us extra detail on the purple parts, but not the black parts, hopefully. Yeah, now it's giving us extra detail everywhere. I guess we might simply just need to put a color ramp in between these to increase the contrast a little bit and make things a little more black. Let's give that a shot. Yeah, that's where the issue lies. Okay, so now we have a noise texture specifically for the purple parts. What I'm going to do for the fangs is very easy. It's the same thing I do for the horns on one of my other demons. So let's add a simple noise texture. You'll note that I use a lot of noise textures because just mixing and matching noise textures is honestly the main thing in my entire workflow to make texture work. Because again, I can't paint things on manually because I suck at that. So that just goes into a color ramp. And that color ramp goes into the base color. This entire thing gets mapping coordinates. We change that to UVs. Actually, maybe we'll keep this one and generate it to prevent the stitch lines. So let's scale these a little bit so that we can see at least some noise variation in them. And then what we do is we just make this a lighter gray color with maybe a little yellowness in it. We make this a yellowish greenish kind of color and pull down the brightness for that a little as well. The colors don't work that well, do they? Maybe if we use the color picker and match that color with... actually, that might be not too bad. And then if we match this other color with the lighter color from that, that is bad, however. But if we make this a little lighter, a bit more yellow, and maybe scale this back, that works well enough for the fangs. And you can see there's no seams here because we're using the generated object coordinates. We could also just use the object. They're very similar, but we have to not scale as much. Effectively the same, or at least very similar. And since these are fangs, which are effectively bones, they don't really need any fine detail to them, and they can be a little reflective as well. So we're going to keep the roughness at about this value. That makes them too reflective. Maybe make them a little more reflective there. Now these little link bits, I think I called them the just material. Okay, let's start with a Musgrave texture for these, and once again, let's keep them at generated for now. We can always move to UVs, but there's not really reason to use the UV coordinates here, I don't think. And I'm using this Musgrave here because that's a very good one to make it so it looks like there's like damage, things are being chipped away from. Because it's got this very blobby consistency where there's a lot of black and then some white parts, and you can use that as a mask to isolate little islands in your object. And as I said before, you can use them very, very well for a grunge or dirt map like this. And I kind of want to have these feel like almost a rusty kind of type, but I don't want them to be actually metallic, because partly because baking things while metallic is enabled in Blender is a nightmare, and then baking the actual metallic map is also iffy, so I'd rather just avoid that. But we can use this in the roughness map, for instance, and you can see that gets pretty close. We probably want to put that through a color ramp as usual, just so that we're not using a spectrum from 0 to 1, because we don't really want it to be at 0. We probably want it to be like 30-ish%. That's more like 50% rough to, well, 100% rough is actually a pretty good range to be at. And we can just like lower this down a little bit. Probably keep the mapping node up here. And let's see what other type of textures we might be able to use. Maybe we can use a Voronoi texture again. I always like using those. Usually they're for more organic type things, but maybe it works here as well. Let's just try and see. There's a lot of settings to a Voronoi texture, so that is always a nice thing to work with. Although I don't think it's gonna do the trick for us today here. But let's make this, for now, similar colors to the colors that we've been using for the body. Put them into the base color and just see what that looks like on the material itself. We're gonna need a little more contrast into that to make that work. I think I'm gonna copy this Musgrave texture roughness map over to the main body material as well, because we haven't had a roughness map for that one yet. And I really kind of like the look of this. You just need to dial in exactly like where the roughness starts. Now, as far as the colors for these chains go, because that's what we're actually working on, I don't think that this noise texture actually works too well. Let's also see what it looks like. The colors work decently well, I think. They're not perfect, but it's just the Voronoi texture is not it. Maybe we use a Musgrave for this as well, or maybe we just go back to our old trusty noise textures, because those always fucking work. Yeah, the Musgrave actually works pretty good. It needs some normals though, still. And we're going to do, again, the exact same technique here. We're going to use this exact same map also as a mask. Which is the great thing about this procedural shit, is you can reuse a lot of the things that you're working with. And now we're going to go back to our good old trusty noise texture, because that remains the most useful texture in all of 3D design. And see how detailed it needs to be in order to make sense. We want to set the factor to 1 to make sense to use in a context like this. Put a color ramp in between here, again for contrast purposes. Yeah, the scale is much too high. Or maybe it's the roughness that's too high actually. Let's put that into a bump node and then into the normal and see what this looks like, because it's probably going to be shit. Yeah, that's pretty shit. If we invert it though, it's probably still going to be shit. Scale this a little more, put down the strength, and honestly that ain't bad. Create a separate noise texture with a slightly different pattern, and that's all there is to it. So put that into there, and now it's going to be like 100% the same, of course. But now we can just like change the scale on this. And if we put the scale for this to like 50-ish, but this one isn't going to be very rough. You can see that it's different to make things rough from being very like finely done through scale. Yeah, that seems about right. And actually, instead of an invert node, what I'm going to do is add a color ramp here, because it gives me a little finer control over what we're actually doing. Because there's these lines, as you can see, right, between the two normal maps. And with a color ramp, I can just pull this white in until that line pretty much disappears. And that's pretty good too. Okay, so we're getting somewhere, because the eyes here and the lines are not going to need actual materials applied to them other than being emissive. Let me show you how to bake this all down into one coherent texture map, or sets of texture maps rather. So first I'm going to go back to the body and re-enable the normal map we've made for it, because again it's pretty heavy, but we're going to need to use it now. And then in every single material we're going to go through and make a image texture. We'll call this the base color, and we'll set a resolution for it. I'm going to at first try 2048 by 2048, because this does need to run in a game engine, and I'd rather not use a 4K texture if I don't need to. There's a lot of detail here, so 4K might be required. Then we make that texture, and we make sure that this base color texture node is selected. Then we just copy that over, and even if a material doesn't do anything with the base color, it's a good idea to still like paste it in, because otherwise sometimes Blender gets a little bit confused. So we paste it in everywhere, make sure that it's the selected node. And with it being in every material now, we can come up here, and as long as we are in the cycles render engine, you probably want to set it to GPU compute because it's faster. We can come down here to the bake menu, and here we can say bake our diffuse, which is the base color, and we're going to only use the color. So no lighting, direct or indirect. And if we press this bake button, it will then bake in every material that has this node selected into this texture, our diffuse map. Which is probably going to take a hot minute, but let's try. You also need to have the object itself selected. That does help. And at the very end of it, we get this texture out of it, which is just our UV islands. We should recognize the rough shape of it with the base color, so no normals, no roughness, no nothing like that, baked onto it. And we can take a look at what's happening here and see if this is detailed enough for our liking. It might not be. And from there, we just repeat that process for all the different type of texture maps that we want. And I like being able to see the colors and things and the textures while I animate, so I know whether or not things look stretchy and how far I can push things before they start looking a little weird. So I want to have this to be able to animate with. As well as this being the version that I actually will be importing into the game because it only has one material slot, which we'll call spider. Because engines like Unreal and Unity automatically see in the FBX, oh, it's got so many material slots, and we'll make, like in this case, 10 materials for the object. Well, we only really need one, and that's going to save you on draw calls, which will drastically improve performance. Next time, hopefully it's going to be a bit of a shorter process, and as such a shorter video. We're going to be rigging this thing up, and then in the final piece of this mini-series, we're going to be animating it. Now that we have a fully textured, fully modeled spider looking thing, it's time to rig it up and prepare it for animation. This is going to be a very rigid kind of rig, so there's not going to be a lot of deformation going on. The bones are going to mostly work on entire meshes as a whole, so the meshes individually aren't going to get too deformed. That's not particularly like a common thing, so if you want a video more about like general like humanoid rigging, I've got a video on that as well, which might be more useful. But beyond the fact that we're not going to be using weight painting and we're going to be directly selecting the vertices that match each bone, there's a lot of rigging related stuff that's going to go on in this video that's still going to be useful either way. So let's get started, shall we? We're going to get started by adding a armature and just a single bone. We'll set that to appear at 0, 0, 0. And I actually now noticed that our origin for our spider is nowhere near where it should be. So we'll set the origin in the center of mass. That seems like a better one. So if we set that to 0, 0, and 0 now. We'll go into the armature here, and we can't see it right now. So if we come down here to the object data properties in the viewport display, we can set it to in front, so we always see the bone. Now, let's go into edit mode and turn this 90 degrees around. Go to top view, and we're gonna line this up with the main body. This is gonna be our main bone. So this is more or less the root bone, right? Then for the back part of the body, we're going to just extrude out another bone. And actually what I'm going to do is I'm going to select it and Alt P and disconnect, and let's scale that down a little bit. Then I'm going to select this first and then the original bone second, and Control P to parent with keep offset. And now if we were to go into pose mode, when I move this bone, the other one moves with it, but this still maintains its individual movement. I know that for most of my animations, if not all of my animations, this bone isn't going to be moving. If I wanted to be able to move the upper body and the lower body here separate from each other, I would probably add in a root bone here that everything is then connected from. And then we'll extrude out a bone here. We will disconnect the bone. Disconnecting still has the parent-child relationship, as you can see through the line, but there's just a offset, the same thing we created between these two bones. And these are going to control the fangs. So put part of the bone there. It doesn't have to be super exact. For rigging purposes, it's going to be nice to have these being in like opposite angles. So this one pointing in this direction, that one pointing in this direction. Because then when we start rotating these, I can just apply the same rotation to this one, but negative. And they will always move together. Now, coming off our root bone again, I'm going to extrude out a bone, just roughly. And we're going to disconnect the bone and move it over to the first leg over here. Make sure it roughly matches. Then this bit is going to come up to the first joint. And usually if you're like rigging legs or stuff like that, you would definitely want this to have more than just one bone. You probably have 3 bones, so you have a little bit of bendiness to it. But these legs are just absolutely massive as it is. And again, these bits are going to remain rigid. So from there, we extrude out another bone. and move it down into the joints. And from there, you guessed it, we extrude out another bone and we move that down into the feet position. And that is the bone structure for each one of the legs. So we can just copy this entire structure over, Shift D to copy. And the heights should all match up because we didn't change those. So just matching up this should pretty much line up as well. And if you name all of these bones properly, there is a symmetrize function in Blender, but I don't like using it because it's a little iffy sometimes. So what we'll do instead, I will set our cursor back to being at 0, 0, at least more or less in the X direction. Then if I select all of these bones and I duplicate them with Shift D and I just scale them in the X with the scaling being done around the 3D cursor, you can see that's a quick way to mirror everything. And that's all of the bones being placed already. So that's fantastic. Now you're going to want to give all of these names, because otherwise, if we go back to the bones here, they're going to be called bone 16, 17, 18, and so on and so forth. And that's going to be confusing. So we're going to name this, and I'm going to name this in direction based on the top view. That's what makes most sense to me. So this will be our Fang R. We'll also have a Fang L, upper body, lower body, and then these legs, we're going to number them 1, 2, 3, 4 from back to front. So this is leg 1, segment 1 on the right side. And then the same on the other side with the L. This is mostly important for things like setting up the inverse kinematics, but also for setting up the weights that we're going to be doing here in a second. Telling the bones which vertices are connected to them. Knowing which bones are what, instead of just having them be numbers, is hugely beneficial in understanding what the hell you're even doing. Alright, with all of the bones named and set up, I don't need anything else that needs to move. So we can go back into object mode here. And we can select the spider first. Then select the bones. Control P. And we can say deform armature. We can make empty groups, envelope groups, or automatic weights. For most of your characters, you're going to want to use automatic weights because that's pretty much good enough, and you can touch up the weight painting manually a little bit. And this will automatically assign weights to your mesh based on where the bones are. So I can just show you what that looks like, but we will not be actually doing that for this object. So now if I go into pose mode here and I move this around, you can see things move, but not quite in the way I would like them to. We can see, and I can actually turn off the armature real quick, that its automatic weight painting includes part of the body and this specific eye, while what it should include is only this ring, not even the chain selected to it, because that's part of the body. This ring should rotate, then the leg segment itself, this ring as well, and then maybe this link, but I think this link actually belongs to the next leg segment. Yeah, because the last leg segment would only have this link and the leg. So it should only have the two circles and the leg in between as pure red, and everything else should be pure blue. So how do you do that, you might ask? Well, if we just made empty weights, we could skip a step here, but I'm just going to show you if you did automatic weights, it's not that difficult to fix. You go into edit mode, and let's go back into here. And what we do is we just select everything and remove it from this vertex group. Then we simply select everything that we want. So that's these three pieces of geometry. And then we simply just assign that to this vertex group. Now, if we go back into our weight paint mode, we'll be able to see everything is blue, except this is pure red. So everything is set to 0. This segment is now purely set to 1. Turning on our armature again, if we now go back into pose mode and we rotate this leg, we can see it rotates exactly in the way we would want it to. And you'll note that I already had this in mind while modeling, right? So everything that needs to move is its own separate mesh. So it's easy for me to just select the linked mesh and apply it to a certain vertex group now. So for instance, I've got the leg over here, and that's just these vertices. And then finally, of course, we do the fang for the left, the fang for the right, the lower body, which is this part, and then the upper body, which also includes the eyes. Finally, when all that is done, oh, of course, the upper body also includes these first chains, because those are going to be stuck to the body. And then we just tab back into weight paint mode to double check if there's nothing that went wrong, because everybody makes mistakes sometimes. That seems about right. That seems right. And that means we now have our proper weight. So going back to the armature now, everything should work marvelously well. Going into pose mode, and we can move everything just as we want to. These ones we can move not too much because they clip through. That's a bit of an issue. And that's because it's a good thing that we really see this now. We probably should be rotating this from a point inside, because now if we rotate this, we'll be able to see it rotates from this point, right? So we get away with a little bit more, but not a huge range of motion. And now we need to try to match this up somehow, which is actually quite important. It's going to be minimal movement in those, but there will be movement, so they need to at least function somewhat well. Now, everything has bones and weights, and now we're gonna get into the actual rigging part. So it's time for some IK. Because we don't want to move all the legs in every animation, like, okay, we're going to, in pose mode, move this, and then this, and then this. Because that is tedious and painful, and tends to just not even look as good, right? Of course, it heavily depends on the kind of animation you're making, but for what we're doing here, we are definitely going to want to have inverse kinematics. So the way we do that is we go back into edit mode here, and we add in a extra bone on the ends of all of our legs. And we should actually be able to extrude multiple at once. These are going to be our IK controlling bones, so make sure to select them, go into the bone properties and disable deform. This way we can actually export the rig without including these bones, which is amazing. Selecting multiple at a time does not work, so you need to actually do them one at a time. I thought it didn't, but I just wanted to double check for you guys. Then another thing we need to do, and for this we can actually select multiple, because they're still parented to the bones that they're extruded from, and that we don't want. So Alt P to clear parents. And now if we move this bone, you can see this one doesn't move with it. We'll also take these joints here, and these are going to be the elbows. So we make sure you don't actually select the entire bone, just the joints at the end here, and just extrude upwards. And we're going to do the same thing here. We want to select them all, and first and foremost clear parent, and then we need to select them all again and disable their deform. And it's at this point that you realize that maybe setting up the IK for one leg before copying everything over is a good idea. And to that I say, yes, it would be. But I kind of forgot to do that, as I usually do. I very often forget to do that. Do as I say, not as I do. You do want to put them up a little higher though. These are the bones that the joints are going to be pointing towards. In theory, that shouldn't be necessary, because I'm going to set them up in such a way that they can only rotate in one way anyway. So we might not actually end up using these, but I've made them now and I'm going to show you how to set them up, and then I'm probably going to remove them. So what we do is we select one of these bones, make sure that we're in pose mode, and then we have this bone constraint properties option. We can add our inverse kinematics here, and we can set our targets and our pull target both to the armature, and then we need to select a specific bone. So we'll look at this bone. This is called leg 1 segment 3 R001. Preferably you would call an IK controller or something like that. At the moment I'm too damn lazy to do that. So we'll just look for leg 1 segment 3 001. That's going to be our target. Our chain length will be 3 because we've got 3 bones that we're working with here. So that's 1, 2 and 3. You can see the yellow line going from this bone to the base of this one, so that's correct. And the same thing we can do here. This is leg 1 segment 1 for the right, and it's 002. So we'll go back here for the pull target. We'll put in R.002 leg 1 segment 1, so that's that bone. You'll see that the entire leg gets rotated, so we'll set the pull angle to 90 degrees or minus 90 degrees to make sure it points upwards. And now when we move this controller bone, we'll see that the entire leg moves around, and it'll always be trying to point towards this bone. That's how you usually set up IK. I'm going to do away with the pull target for now, and you'll see that we can still move the leg around, but it's just not influenced by this bone whatsoever. Then in our bone properties here, we can actually on a per bone basis influence a few things, like the stiffness of the rotation. So that's how much the other bones will need to rotate before this one starts to rotate. That way, oftentimes you don't want the hands of a character to rotate as much as parts of the arm, so you can set the hands to being stiffer. We can also limit the rotation for certain axes, and if we just set the limit for X and Y, or Y and Z rather, to 0, that should now mean that this thing can only ever rotate itself in the X direction, which for the mechanical thing that we are doing is actually great, because now we can literally just move this up and down. We can move it away if we wanted to. Like, the IK itself still works fantastically. It's just limiting how it can physically rotate. But if we're going to set these to being limited to 0, we can just come up here instead and lock those axes from moving altogether. Just wanted to show you the limit function, because something like an elbow shouldn't be able to bend backwards, right? So you can limit its rotation. But if you just don't want them to rotate at all, just lock those axes, and that's effectively the same thing. And that is the reason that I said that I don't really want to use these IK pulls, because there's not going to be a lot of rotation going on anyway, other than around its own turning axis. So we don't really need these. Now I have all of the bones that I want the constraints on selected, with the one that has the constraint already on it selected last. So I can just copy constraints to selected bones. Now everything will be put on those constraints, but they all have the the wrong targets. So we'll see this is leg 1 segment 3, so that makes sense. This is leg 2 segment 3, so what we'll do instead is we'll change this to the controller for leg 2, and then it matches up to the location where it should be, and we'll just do that for all of them. I'm going to extrude out a new bone here, going into edit mode, disconnect this bone as well, and what this will do is it will control the rotation for the 2 fangs here. So now all we want is when we rotate this one up and down, these ones should rotate in the Z. So what we will do for that is we'll add a transformation constraint, set the target to being this bone, which is called upper body 001. So we'll get our upper body 001, and then we'll map from and map to. This can stay the same, and then the rotation will change our source Z axis to be taken from the X. And we set the max here to 360, and we should probably set the minimum to minus 360 just to be sure. And we copy the same things down to here. And we can see that now creates a rotation where if we rotate this in the X, this rotates appropriately in the Z, but it's a little inverted, right? And you can do a lot there, but I think just rotating this 180 degrees on the X and just moving it out a little bit is probably the easiest way to deal with that. So now we've got that linked up, and we can just do the same thing we did before, and that's copy the constraints. Now they move both in the same direction, so we'll take this one and we'll change this from negative 360 to positive, and the bottom one from positive to negative. And now they've got the inverted movement. So I can control both of those fangs with a single rotation of this control bone. I've been messing around with trying to copy location constraints and stuff like that to make it easier to animate in the next part, but nothing is really working out that well. There's a lot of weirdness going on. So I'm just going to manually animate both sides of the body, which is not ideal, but I'll do. It's not worth me spending 2 or 3 hours troubleshooting rigging stuff, while the animation process would only save half an hour if I did that. So I'm just going to leave it for here right now, and that means a little bit more work next time, but in the grand scheme of things, I'm 10 hours into this character. I'll take an extra hour of work to just move on. We've got this thing all rigged up, ready for animation, and let's get into animating it. So I'm going to change up my workspace a little bit to have a couple more windows here. So first and foremost, we're going to change this to non-linear animation, and we're going to change this to the dope sheet, and then specifically to the action editor. We're going to make a idle animation, a walking animation, a attacking animation, and a hurting animation. And maybe I'll make another one if I come up with a fun idea. So let's start with the idle animation, simply because it is by far the easiest one. And we'll do that with starting up a little higher. We've got inverse kinematics for all of the legs here. So we literally only need to key whole character here, and then go to 40 frames in or something like that, and move the whole thing down, keyframe again. And actually, as a matter of fact, let's add in another window here real quick and make that the timeline, and auto keying should be on. Then we'll select everything. So actually, we only really need to select this one, and then to 80 frames, and there we go. So now we've got a decent idle animation. Maybe it is actually dipping down a little too low, actually. Maybe that looks pretty good. And that's why you set up inverse kinematics, because it makes this entire process so much easier. Now, we need a little bit more detail in our animation than just that, but we're going to limit ourselves here to 80 frames in length, because that's how long this loop takes. And in that 80 frames, I'm thinking let's do something where this moves a little bit as well, so it feels a little more alive, right? And then at the very end it should move back up, and there's no real necessity to have this match up. So yeah, that feels a bit more alive. There's a little stutter at the end of the animation when it loops. That's just a blend playback. That's not actually in the animation, so that's fine. And then we'll get this. We've made a rig where it's easy to animate these fangs, so we can just every 20 frames loop that around, and we'll very easily create a movement in the fang as well. And there we have a idle animation. There's a little something going on here which I don't particularly like, because those are disconnected. There's also something weird going on here. Hold on. It isn't the easiest thing to animate, because while there's no weird stretching going on, things needing to interlock means there's a certain amount of precision required, which is not necessarily my strongest point. So needed to fix up some of the rigging we did in the last video. Now let's show them as sticks, just because it shows the actual model a little bit better. I think this is pretty good. Like that little lag over there is a bit weird, but that really is the only thing that is doing anything wrong. So with how much of a headache this entire thing is going to be, that's fine. So we just push that down and we call that idle. Then the attacking animation, the visual effect for it is going to be done in Unity itself, but all we need to do for that is... Good question, what are we going to do for that actually? Let's keyframe the whole character and then 20 frames move you down. No, move you down a little. What happens if I rotate this one? It actually works remarkably well. And at the same time we can animate this one. Animate that on 30 frames actually, instead of 20, so that it keeps moving a little longer. Animate that up, so we have... Probably could stand to make that entire thing much faster, like twice as fast. And then maybe move you back, so we have a little bit of wiggling going on there. Move you back faster. If you've seen my 5 animation tape videos, just make things faster. They tend to look better. That being said, that's not the issue here. The issue here is one of weight and timing. And I think the issue will be resolved mostly through the fact that the body has to react as well. Let's see, that up and then down. We move you a little up and then rotate you further ever so slightly. And from there, this is going to need a looping idle animation as well. So this is actually just the attack enter animation. That's everything there is to it. 20 frames long. That works for me. Yeah, no, that's fine. Because then from there we can just use this exact same pose here. So we can just insert a keyframe for the whole character. Put that on frame 0. Seamlessly will go between those animations without any blending being needed. And from there we can just make a faster version of the movement we had for the normal idle animation. And we can make that one as long or short as we want, really. So let's make this one 90 frames and see what that feels like. This version needs a little rotation to it as well, I feel. It's a little too fast. Let's try making it 120 frames long. Okay, that's pretty good. It's a little stiff, I'll give you that. But we're going to be animating this part of it as well. And since we've got a total of 120 frames, if we move them every 30 frames like this, we'll be able to properly loop as well. I actually think that's still too fast. Let's remove these last two, and that then... Yeah, that then makes the same timing as this, which is not great. Maybe the movement doesn't need to be slower, it just needs to be smaller, because that's quite a big movement. So what if we make this movement slightly smaller instead? I think that is a good alternative. And we can add a bit of variation to it, right? This one can be a little bit more to the left, and then this one can be slightly more to the right. Add a little liveliness to it as well. And then of course we can animate the fangs to do just something. Doesn't matter that much, we can just open them up a little bit, close them down a little, open them back up and close them. And I don't think the timing for this is going to look particularly great, but maybe... Well, that's actually a little too far, that's going to clip through. And that's the attacking animation. Doesn't seem very attack-like, but the attack is going to come out from here. It's going to be like a force field shield around it. So this just loops a random amount of time, and then we move on to a exit animation. So we can push this down as well. And this one doesn't necessarily need to 100% match the last frame of the looping animation, because this one is going to blend in. It could be transitioned to at any given time during the previous animation, because there's some randomness to the length of that state of the attack. So we can simply get a pose that looks decent, use that as a reference for the whole character for the start, and then I want to put in another keyframe here for the, if I clear the transform, just like the normal default state of it, with the only difference being that the fangs don't clear their transform. And that's really all there is to the exit animation, I think, because it could be a little fast, admittedly. Because after that it's going to go back into its idle loop or its walking animation or whatever. So sometimes animations can be as easy and as simple as that. So that's attack. Now the hurt animation is going to be a little tricky. So let's actually start with the walking animation here. So we simply select every bone except this one, because we don't want to clear a transform on that one. We go back to our clear transform, our default state. And because our rigging was a little uncooperative, what we're going to do is for this one, we're going to set a keyframe for influence to being 0, so it doesn't use inverse kinematics. We're going to animate this with forward kinematics, meaning that there's going to be a lot more work here, but also a fair bit more control. Okay, this is the animation that scares me for having to make it, but let's get started with these two legs. As I explained in the last part, but maybe you haven't seen that, spiders tend to walk with pairs of legs that are on a diagonal moving at the same time. So this leg and this leg should move at the same time, and then I think this and this, this and this and this, and the last two all should move in pairs. There's also the issue of the fact that how I modeled and rigged this. I can only really move these things in their local X rotation. But for an effective walking animation, you would also usually require a rotation in the global Z. I'm gonna try just making an animation with a up and down motion that doesn't include a forward motion, and hope that just moving the object forward in game in combination with the legs tapping up and down does the trick. I'm not sure that it will. So let's start off with this leg going up and then taking this leg going up as well. And we're actually going to be like unbending these quite a bit. Do mind the fact that I'm in local space, so I'm rotating these things around our local x-axis. You know what? Actually what we're going to do is I'm just going to do all of these legs at the same time, and then I'll change their timings, because they all need to make the same movements anyway, right? So if I make sure that this is an individual origins, I can just move all of these. Well, this one is facing the wrong way, so that's a little awkward. Upward on the 10 frame mark, and then the second segments are next. Some of these are facing 180 degrees the wrong direction, so while their axis still makes sense, their orientation doesn't. So we need to manually go over that. This is again, much like I said in the last video, which again, if you haven't seen that, I'll just reiterate here. If this was a character that I needed to animate a lot more and make a bunch more animations for, it would be worth now going back in and changing the role for all of the bones that have this issue, so that the actual animation process becomes easier. But I'm like already 80% the way done animating this, and the only real animation that gets impacted by that is the one I'm making right now. So I'm not going to fix it, I'll just deal with it. Now I'll also make this a little slower, so it'll all happen over the course of 40 frames. Which makes it a little easier to say the timing for this and this set is going to be shifted 10 frames to that side, And then the timings for these, which match, I believe, these. I'm not an insect. I know spiders aren't insects, but I'm not an insect expert, so maybe 5 frames to that side. Actually, let's go for 10 frames to that side. Okay, so now I've got everything selected that's part of the same group here, so we can... I'll worry about making it properly loop in a moment. Just give me a moment here to get all the timings right. That seems to loop reasonably well. There's a little fuck up here, but I think if I just move this frame over to 120, that should resolve that. Okay, this loops. Okay, now, the actual movement of the body. First and foremost, I think it will help if we animate the back part of the body to move up and down. You see, because there's 8 legs, the usual like contact, down, up, passing pose structure of a walk cycle gets significantly complicated and really doesn't work all that well anymore. I'll give you one thing. It doesn't feel as janky as I thought it would. I just realized another issue as well that I'll let you think about what the issue is. Have you figured it out yet? Because this is where the feet land, and this over here is the lowest point of the body, meaning the body is gonna clip through the fucking floor. The feet need to be lower down, which is not that difficult to do. Just I wish I thought about it earlier. Because it's just a matter of getting the down position for every bone. Let's see, this is the up. The middle here is the down position. Okay, now that I'm doing this actually is starting to feel like the difference between the right side here and the left side. Like this is starting to feel like it's actually walking. So just doing that little bit of extra work, turns out that is highly worth it. And also because I now know that this actually looks a lot better, that is highly motivating. It works well enough for me. So let's say 56 frames long and push that down. I'll split this strip, say fuck off to both other sides because I can't be bothered to deal with any of that shit. Now let's go back over the other animations and check what the... Yeah, I was afraid of something like that. First of all, these all need to be set back to influence being fully on. And then after I've done that, I need to go back into the walking animation and check if that's fucked up anything there. It shouldn't have, but there could have. Need to be moved down a little. Tiny bit more. Actually, can I try to use that as just a copy paste? I can. That is fantastic because that means that everything is going to have the same amount of height, which is perfect, because otherwise the feet would be blending up and down all the fucking time, and we don't want that. Okay, that's fixed a lot of my issues. I was real nervous there for a moment. And for the very last animation, we'll do the hurt animation, and we probably want to have 3 variations of that. So we'll make one of them and then copy that over twice and modify to just change things up a little bit. The issue is usually with a hurt animation, I would do something like going like 10 frames this direction and just rotate the body. But that doesn't work that well, so maybe we'll need to do something else. Let's see, what does that look like? Actually, that might not be so bad if we then also... Is IK enabled for these? It is. So if we just... It's going to be a little iffy to get this working. What does that look like? That's actually not too bad. Get these lined up as well. making it a little faster, probably not a bad idea. It can be a pretty quick animation, 5 frames, something like that. And then the entire body at 10 frames goes back to where it was at. So I think the movement could be a little bigger. So let's try and move the body back as well and rotate it just a tiny bit more, and rotate this a tiny bit more as well. And in order to really sell the fact that it's getting like pushed back, what we're doing right now is we just more or less do a ping pong. So what I want to do is at like 8 frames, I'll select everything, copy over that keyframe, and this is going to go to like 15. Let's go to 9 frames actually. And just like extrapolate a little bit further from where the initial movement went, but much more subtle. So that way we have a quick movement, a little bit of hang time where it's not entirely stationary, it does need to be moving. So probably a good idea to like put the legs somewhere around there as well. And then let's move this to 20 to make its fall back down slower. So that's pretty much good enough for our herding animation. That works relatively well. And this is really where the IK comes in handy, right? Because all of these bones, they just do what they need to do when the body moves. So we can push that down and we'll call that herd 1. And then we'll Shift D to duplicate it, call that herd 2, and edit that action. And then all we need to edit is these 2 keyframes. So let's make one where we move a little towards that direction, and then we'll need to figure out a little bit of work for the legs as well to make them not glitch out too much. But now we have a slight variation where he leans into this direction, right? And as a matter of fact, I think it'll be nice if the lower body does a similar movement to give it, actually it could be quite a bit more to really give it the feeling that it, I'm not sure why, but I feel like maybe moving it up here a little bit will, it's not really getting too much weightiness to it. I don't think moving it is a good idea, but we can try. That's good enough. And then for herd 3, what we're going to do is, first and foremost, we're going to name it herd 3, not 4. And then we'll just edit this action to do the same thing pretty much, but the other direction. So this is going to bend over in that way. And then this is going to bend over in that way even more. I think at this point the movement itself is much more extreme on this one. It's not too bad actually. And we clearly need to figure out these legs a little bit, because this is not this is not going too well. So let's try to figure out these legs a little. Give them a little bit more room to move, maybe. Actually, we want them to move inward, is I think what I'm seeing here. And don't move them up. So when we move them inward, eventually this one does not. Okay. Hopefully for this one it'll work. It does. And then at this frame, we'll see if we can fix up the legs even more. There's not a lot of fixing that needs to be done. This all works out well enough. And for a quick herding animation, that is good enough. So then when we go to export, first and foremost, I want to save. But then when we go to export, make sure that none of these actions are highlighted. Otherwise, that'll be the only animation that actually gets exported. So we've got all of these separate actions now. We can go to File, Export, FBX. And here we have the folder that we're going to export into, which is all fine. That's perfectly valid. And we actually want to give these things a proper name. So let's call this skeleton armature, or spider armature rather. and this will be spider mesh. Then we'll turn off the sun from being visible, because now we can say include only the visible objects. So now it'll only include things in this FBX which are visible in our outliner. You could also say only selected objects. That works perfectly fine as well. Or you could put them all into a collection and only export the active collection. There's a lot of ways to do this, but things like the light that I haven't deleted and like the high poly version that might still be in the Blender projects that you want to have for reference purposes or for future use, you don't need those in the FBX. Then geometry we can ignore. For the armature, we're going to only use the deform bones and not add any leaf bones. And we want to only export the NLA strips, not the actions. It's a little annoying because to me it makes sense that it would be the other way around. But the strips are the actual blocks that we see here, that we've named. The actions are the tracks themselves. So if you're making animations and you're blending between two animations or something like that, if you export the actions, it'll export the blended version. So it's a useful thing to have, but generally this is the way in my workflow how I animate things. So I just export the NLA strips and then we'll export this as the spider FBX. Then in your engine of choice, in my case right now that will be Unity, we just drag it in and we can see we have a spider here. And in there we have all of the individual animations. So this is our idle animation, our attack enter animation, attack loop, and so on and so forth. The walking animation. We've got our one single material that we can apply those texture maps to that we have made in a previous video, and from here on you can start coding everything you want for this specific enemy, which will not be part of the series. This is specifically about creating the character and modeling and everything like that. So if you've enjoyed this video or this entire mini-series, don't forget to like the video and subscribe to the channel for more content much like this. And if you want to support both this channel and the ongoing development of this video game, there's a link down below in the description to my Patreon where you can subscribe for any tier you want. If you go for the Cave Dweller tier, I believe, or above, you get access to all of the project files for the tutorials that I make. So it's a very good value, well worth your time. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page.